All right, we are jumping back into statistics and reviewing some of the things we went over really quickly before map testing. So today's focus is going to be on the MAD, which stands for mean absolute deviation. So remember, mean means the average, so we're looking for the average. Absolute means we don't care if it's above or below the mean, but just how far is it from the mean. Deviation means varying from the norm. So we want to know, on average, how far do the numbers vary from the center of our data. So let's take a look at this data here. We're looking at films. Successful films in the US. This is how much they made in millions when they were released. So we have E.T. at 400, Forrest Gump at 330, Independence Day at 305, Jurassic Park at 357, and The Lion King at 313. So the first thing I need to do is find the mean of this set of data. So hopefully you remember to find the mean. The mean is the average. Don't you hear me say? Add them all up and divide away. We have to fair share this money out. It's not fair that E.T. makes 400 million and poor Independence Day only made 305 million. So let's fair share those by adding all those pieces of data together. 400 plus 330 plus 305 plus 357 plus 313. And you still have calculators to use during this. You will have calculators on the test. So we have 4 plus 330 plus 305 plus 357 plus 313 equals 1,705. So that's how many millions we have to share equally between these 5 movies. So we're going to take 1,705 and divide it 5 ways, and each movie will get $341 million. Not a bad way to spend a day making a movie. So that's our mean. This is the center of our data. So now our job is to find what the average distance from this 341 these movies are. So what I like to do is create a table. Here's your data, here's your deviation, and I just do the absolute deviation in one step. So instead of doing a negative or a positive, it's just whatever the positive is, however far it is. Remember, we don't care if it's to the left of the mean or to the right of the mean or the center. We just care how far away it is from the center. So starting with 400, I'm going to do 400 minus 341 to see what the difference is there. And 400 million is 59 away from the center, or 341. Then I'll do the same thing with 330. That one's a little easier to do in my head. It's 11 million away from the center, so it's a little closer. Then we have 305. I'm going to use my calculator for that. 305 minus 341. It's negative 36 million away, but again, we don't care if it's to the left or to the right, under the mean or above the mean. We just care how far it is from the mean. So that one's a positive 36. Then we have 357 minus 341. 357 minus 341. That's 16 above the mean. We have 313 minus 341. That's negative 28 below the mean, but we don't care above or below, just that it's 28. 313. 28. And 1, 2, 3, 4, 5. So those are all my 5 movies. These are how far they are from the center. So now we have to find the average of these. So to find the average of these, we're going to add these all up and divide away. So again, 59 plus 11 plus 36 plus 16 plus 28 gives me 150 divided between the 5 movies. They have a MAD, or a mean absolute deviation, of $30 million. So on average, here's the center of the data varies by $30 million above or below that center, or to the left or to the right of that center. That is how you find the mean absolute deviation. First, find the mean of your set of data, then find the difference between each data point and the mean, then find the mean of those differences. A lot of mean going on. Hope you still stay kind out there.